from here and one H here. OH plus H yani H2O, water. So what is the remaining structure? C, double bond O, NH. So this is a very strong peptide bond. Okay, this is a covalent bond. And after binding of different amino acid with peptide bond, you have a primary structure. And there is a strong link between structure and function. Yani, a structure determines the function. Okay? About the properties, this slide is important. Maybe I ask you some true and false question from this slide. Okay? So the concept is important. At first, peptide is amide linkage. As I mentioned, it formed between carboxyl, amine hand actually. And you should know that they are very, very stable. But have you ever heard the name of denature? Nature means that normal. D means that DE, yani you take. Denature, it means that you take its normal nature. Okay? For example, exposure, for example, if you put your protein in a boiling water, if you put your protein in a very strong acid, a strong base, it can cause the actually peptide bond. About the characteristic, what is important here? Just know that. Please tell me, which form do you think is more stable? Cis and trans?
Cis. Not trans? Okay.
Cis or trans? You can explain why trans or why cis. Are you familiar with the steric interference? ممانعت فضایی فارسی. You know, some groups repel each other. Whenever you have some large group, they push each other. Okay? This is known as a steric interference. Okay? Because of the avoiding of steric interference, the trans is more stable. Okay? Another point of this slide for your final exam. Maybe again I ask you about some true and false question. Maybe I ask you, peptide bond is a single bond. No. It is double bond. No. This is partial double bond. Yani between single and double. Okay? And also it contains actually planar, as I mentioned, trans. Maybe for example, I ask you peptide bond contain a negative charge. Correct or false or true? Peptide bond yani this one. C-O-N-H. I'm talking about this bond. Is it containing negative charge?
Yes.
No, negative charge. Can you see any negative? Not electron. Not electron. Negative charge. Absolutely it contains electron. What's negative charge? No. Positive charge? No. So peptide bonds are uncharged, but polar. So I want to direct your attention to these keywords. Uncharged, polar, transform, and partial double bond. Okay? These are keywords for true and false question from this slide. About the secondary structure, you know, at first you have, for example, one string. For example, we don't have any equipment here. For example, this is the first structure. Okay. Following the fold of your, for example, primary structure, they increase the level of structure into the secondary structure. You know, secondary structure or the regular form of your protein. For example, sometimes this string, for example, amino acid, at first you should know that amino acid string, they have a direction from N terminal to C terminal. What does it mean, N and C? I mentioned that amino acid, when they bind together and form a first level of structure, primary structure, they have a direction. You should know that absolutely we will have a one free amine hand and free carboxyl. For example, you connect the amino acid together. Amine take a carboxyl. Amine take a carboxyl. Finally, at each end, you have a one free amine hand. It's known as the N terminal. And finally, you have a one COH hand, known as the C terminal. Do you understand? One free amine and one carboxyl. Sometimes they form some helix, like alpha helix. Sometimes they form a zigzag. Are you familiar with the zigzag? Beta sheets. And sometimes they form a beta terrain, actually. I will talk about these points. So, what is important in this slide? You should know that alpha helix, beta sheet, and beta terrain, this is the most simplest question, are example of primary structure, secondary structure, okay, or tertiary. This is secondary. Okay, about the secondary structure, as I mentioned, we have a different form. Alpha helix. And also about this slide, maybe I asked you about some true and false question and some points. Bismillah. What are the characteristics of alpha helix? You know, if you open the structure, we reach to the primary structure. At first, you should know that alpha helix is the example of secondary structure. About the direction of your spiral, this is right-handed. Okay? Right-handed. It rotates toward to the right. Whenever you have a left-handed, like actually collagen I will describe. Okay? So the first important point is that alpha helix is a right-handed. The rotation is toward right. About the site of the amino acid side chain, as you can see here, the R group of amino acid, they extended outward of the helix. They are not in the helix because of, again, actually steric interference. The most, in my opinion, the most important point of this slide is this point. Hydrogen bond. If I ask you what is the type of the bond that stabilizes the alpha helix, this is a hydrogen bond. Okay? The between, for example, carbonyl and amine group. These are hydrogen bonds, and they are parallel to the axis. And this is not important. For each term, you have a near 4 residue. This is for more information. But about example, if I ask you which proteins are full of helix, their structure is full of helix. This is the creatine and myoglobin. Okay, these are important points of this slide. Also, we have some important amino acid. About, as I mentioned, about the number of amino acids for your level, there is no. But there is a question. Could any amino acid locate in a helix? No. At first, you should know that proline disrupts the alpha helix and insert a kink. Kink in Farsi is zaviye, angle. Okay? Because proline is an amino acid, is not suitable for the helix. So if I ask you which amino acid insert a kink, means zaviye angle, this is a proline. And also some large amino acid, some charged amino acid, they are bulky amino acid, they are not suitable for the formation of the helix. Another form of the secondary structure is a beta sheet. I will explain in this slide. You know, beta sheets, as I mentioned, they are zigzag, exactly like a paper. If you fold the paper and open, it forms a zigzag. And this is an example of the beta sheets. At first, you should know that beta sheets are another example of the secondary structure. Sometimes they are parallel and sometimes they are anti-parallel. What is the difference?
They're best if they're parallel, they're in the same direction. If they're not, then one goes to like up and the other one goes down.
Yes, as your friend mentioned, the direction is similar. N to C, N, C, N, C. So they are parallel. But whenever the direction is different, N, C, N, C, the direction is different, okay? So this is an anti-parallel. But, for example, you want to form a 3D structure. You know, at first you have one primary structure. This primary structure form a helix and also they form a beta sheets. But who can provide the link between different secondary structure? This is a beta turn. Okay? So, beta turn connects alpha helix to alpha helix. Beta sheet, beta sheet. Alpha helix, beta sheet, okay? They connect a different secondary structure. What is important in this slide? Absolutely this point. If I ask you which amino acids are suitable for the beta turn, at first, every amino acid insert a kink is very suitable for make a turn, exactly like a car. Okay? And the smallest amino acid, glycine. Okay? So glycine and proline are the most important for the formation of the turn. Or beta bend or reverse turn, they are other names. These are for more information about the motif, about the example of the motif. You know, motif is a combination of the different secondary structure. As I mentioned, these are for more information. But about the another level of structure, this is the tertiary structure. What is the tertiary structure? This is the 3D form of your protein. Okay? At first, I want to review. Primary structure, folded alpha helix or beta sheet secondary structure, and following the combination of the different helix. While you are talking, after combination of the beta terrain, alpha helix and beta sheet to form a tertiary structure. What is important in this slide? At first, you should know that this is a functional form of the protein. As I mentioned, 3D structure. And about the location of the amino acid. Please tell me, you have one globular protein, for example protein, okay? You put in a water. This protein you put in water. Water yani aqueous solution. Please tell me, Which amino acid are on surface? Polar or non-polar? No, it's better to draw. You know, you have this protein and put in a water. Please tell me which kind of amino acid on surface? Because one of the sample questions is the localization. Polar, excellent. Because they make a connection with the water. What about the core of amino acid, inside of amino acid? Non-polar. But I want to change one question. You have another protein. Please pay attention. You put in an oil. And for example, what is the oil example? Lipid bilayer, phospholipids. So for this point, please tell me, what are the nature of surface of amino acid? Non-polar. Do you understand? Because these are actually hydrophobic interaction. Are you familiar with the hydrophobic interaction? What about the inside of this protein? Polar. And as I mentioned, we described this point, what happened in aqueous and what happened in a lipid membrane. And about just memorize the name. If I ask you, I want to review the question. What is the key bond, important bond in a primary structure? Peptide bond or amide bond. In secondary structure, which bond? Hydrogen bond. Absolutely peptide bond is present. But which bond is important for stabilization of the helix or beta sheet? This is the hydrogen bond. About the tertiary structure, covalent bond. What is it? What is the name of this bond? Disulfide. Okay? So, cysteine bind to cysteine. They form it, please tell me, then one cysteine plus cysteine. What is the molecule? Cysteine. Cysteine. Do not make a mistake. One cysteine through the disulfide bond to another cysteine, they form a cysteine. Okay? Another bond is hydrogen and hydrophobic interaction. I know that you are familiar. Are you familiar with this bond? Because in the next session I will talk about this point. Salt bridge, yani ionic interaction, yani electrostatic, they are synonym. Okay? Because I want to talk about in hemoglobin. So in hemoglobin, when I mention that salt bridge, yani attraction of positive and negative ionic bond between positive and negative, you have a salt bridge. And about the denaturing of the protein, as I mentioned, sometimes you have a normal protein. If you open the structure, it means that you denature. The reverse reaction now as a renaturing. Okay, denature, renature. And whenever you unfold your protein, in which situation, as I mentioned, a strong acid, a strong base, I do apologize, detergents, they are considered as a denaturing agent. And when your protein open, I mean denature, it's insoluble and precipitate. These are important points in this slide. Okay? About the denaturing agents and what happened after denaturing, they became insoluble and precipitate. And about the last slide of this session, this is a quaternary structure. What is the quaternary? Who can explain what is the difference between tertiary and quaternary? When we have a quaternary,
the percent of water is high.
no.
More
No, it's not related to the solution. It's related to the structure of your protein. You know,
Contain polypeptide units?
contain more than one. You know, for example, you have a one folded protein. For example, this is, I don't know, one protein name has an X, okay? When I open in the structure, I have only one N-terminal and one C-terminal. Whenever you have only one string, one polypeptide chain, the last level of structure is tertiary. But sometimes you have some proteins. When you open completely, you have more than one string. N-terminal, C-terminal, N-terminal, C-terminal. So whenever you have more than one polypeptide, when they folded, they form a quaternary structure. Okay? So, oligomeric yani more than one chain is present, they consider as a quaternary. And what are the name of the molecule, actually bonds that stabilize? Hydrogen bond, ionic bond, hydrophobic interaction, exactly like a tertiary. But sometimes they can act independently, sometimes they act cooperatively. I will discuss about the last line in the hemoglobin. So, we have a 4 level. I want to review because this is the last slide. The primary structure. What was the bond? Peptide bond or amide bond. You increase the level of structure. Secondary structure. What is the example? Alpha helix. Example. Alpha helix. Beta sheet. Beta term. What is the stabilizing bond? Hydrogen. Excellent. And about another level, tertiary. Tertiary, in which situation you have a tertiary? Only one string is present. We have a hydrophobic interaction, salt-rich, different type. And whenever you have a more than one string, you have another level, quaternary, and it contains, as I mentioned, more than 2 polypeptide chain. And like a tertiary, you have a hydrogen bond, ionic bond, hydrophobic interaction. And the most important example of the quaternary, this is a hemoglobin. And inshallah, in the next session, after the rest time, I will explain. Many thanks. I will start at 10:15, okay?